One of the applications I like to look at involving differential equations is compound interest. Think about this. Think about if you invest a certain amount of money in an account and you want to talk about the rate at which that money grows over time. So that would be dA dt. The rate at which A changes, where A is the amount of money in the account over time. Now, we got to think about, well, what influences the rate at which your money grows? Well, it's the interest rate. And in fact, if you think about, if you have a given interest rate, let's say an annual interest rate of R, your money is going to grow dependent on what that R is and how much money you have in the account. In fact, this would be a differential equation that would model in an investment of a lump sum, and then you just sitting back and watching the money grow every year. The rate at which the amount of money in the account changes is directly proportional to the amount of money you have in the account. In fact, the constant of proportionality is the interest rate. So what that means is, if you have just $1 in the account, every year you're not going to see that account grow by very much, a few cents. However, if you have $1 million in the account, you're going to see a substantial more amount of money every year. So the rate at which the amount of money in the account changes is directly proportional to the amount of money in the account. Well, that's a simple differential equation. Let's spice it up a bit. Let's suppose that every year you're going to add a certain amount of money into the account. Let's call that amount K. So now you see a little bit more complicated differential equation, but still a simple looking one. And it says the rate at which the amount of money in the account changes is directly proportional to 1, the interest rate times the amount of money you have in there, plus the amount of money you add on an annual basis. So we have this differential equation. Now, what we got to do is we got to solve this one. So here's what we do. I figure out how I'm going to solve that. And I think what I'm going to do is I recognize that I'll just call this A prime minus RA equals K. And this looks like an equation that we can use an integrating factor on. And in fact, the integrating factor would be e to the negative r dt. So, and in other words, that would be e to the negative rt. Yeah, there's our integrating factor right there. Now I'm going to go through the process of solving this with the integrating factor. Remember what we do, we multiply through by e to the negative rt. So I've got A prime e to the negative rt minus ra e to the negative rt equals k e to the negative rt. You don't have to go through all these steps, of course, but now I can rewrite this left-hand side this way. D dt of e to the negative rt a. Okay, and notice that is the left-hand side there. And then over here, of course, we've just got k e to the negative rt. Now, let me integrate both sides. So I'm gonna slap an integral around both sides, and I get d dt e to the negative rt a, and this over here is going to be k e to the negative rt dt. Okay. So what we get then is we get e to the negative rt a equals, now this right-hand side is easy to integrate. We're integrating with respect to t, remember. So this is going to be negative k over r e to the negative rt plus a constant. Got to remember that constant over there. And now I'm going to divide through by e to the negative rt, and I get this. I get a is equal to negative k over r plus c e to the rt. See, I just divided everything by e to the negative RT. Okay, now I've got that constant there, that C constant. Now remember, K is the amount of money that you're going to contribute annually. R is the interest rate annually. But what I don't know is the C. Now, I can find C by saying, okay, the initial amount of money I invest is A naught. And then I can just say, okay, I'm going to put a 0 in for T. Okay? And then I have this. I have A naught is equal to negative K over R plus C. And then C would be equal to A naught minus or plus K over R. Now I have my model. A equals negative K over R. And remember, K is a known quantity. It's a known amount. It's the amount we invest annually. R, we're given R. We know we have the interest rate. But now let's see what C is. C is A naught plus K over R e to the RT. There we go, e to the RT. Now this is our model right here. And we can use this model. Let's suppose that we know A naught, we know R, we're given that, and we want to find how much do we need to invest to have a certain amount of money. Well, we would solve for K. We would put the amount of money here. We've got our interest rate, and let's say we're given time, and we want to know, okay, for a given period of time, how much do we need to invest to have a desired amount? Let's say we want $1 million. Well, we would put $1 million here. We've got the initial amount here, and we know our interest rate. We just solve for we solve for K, and there you have it. So this is another situation of a beautiful differential equation, just very simple. And we use our calculus skills, and we get down to this model, and now we can do some pretty good computations.